If you choose any random spot on this earth and then you stand there and then you wait and then you keep waiting for, let's say, around 400 years, one day will eventually come when you'll notice that something strange will happen. During the day, you'll see that the light slowly starts to dim without any clouds in the sky, and the temperature also begins to drop. Just a couple of hours later, you'll see the last of the sunlight disappear, and you'll see that the whole sky is thrown into a deep twilight. The sun is visible in the sky like a black hole ringed by coronal streamers of light. Congratulations, you have just witnessed one of the most rare events in the history of this planet, which is a total solar eclipse. And one thing is for certain, that you can never look at the world the same way again. My name is Shivam Bansal. I'm an amateur astrophotographer from Agra, and I'll be sharing my journey with you all today about how a childhood passion about space led me on a 9,000 kilometer trip to one of the most remote places on this earth, which is the Australian outback, in search of the greatest prize in amateur astronomy, which is an image of totality. Ever since I was a child, I'd been interested in all things about space. I remembered watching documentaries on Discovery Channel and on Nat Geo, as well as reading all the books about space that I could find, even watching YouTube videos when YouTube started along. Then, when I was 16 years old, I got my first telescope. So it was a small and inexpensive scope, but it was still designed for actual astronomy, compared to those toy scopes you see in stores that don't really give you much results. So that night I went out with an app on my phone that I used to identify objects in the night sky, and I turned my telescope towards Jupiter. What I saw next was life-changing. I could see the bright planet Jupiter, and alongside it I could see the 4 Galilean moons of the planet. Saturn was as amazing as I read about in photos, and I could see the color of Mars as well. But I think that seeing the rings of Saturn with my own eyes was a turning point in my journey of astronomy. Suddenly, I wasn't just a passive participant, but I was an active participant in shaping my own understanding about the universe. Suddenly, I wanted to photograph every single planet, every nebula, every galaxy that I read about. So in 2019, I went to New Zealand and I saw the Milky Way for the first time with my own eyes. In India, especially in Indian cities, most people haven't even seen the Milky Way because they live in light polluted cities. But some of you who might have traveled a few hours away from city lights, you must have seen how many stars you can see in the night sky. So at that time, I didn't really know how to do astrophotography, but using my limited knowledge plus a small camera that I had, I got this picture, which was my first picture of the Milky Way. But this really opened the floodgates for me. I really wanted to start photographing more deep sky objects. So the first thing I needed was an equatorial mount. This is a mount that tracks the night sky and moves my telescope along with the motion of the night sky. It is aligned using the North Star as a guide. So using this mount plus an 8-inch reflector telescope, I started getting much better photos of Jupiter and Saturn. So here you can see we have Jupiter, and you can see the great red spot, as well as its largest moon, Ganymede. And you can see Saturn in all its glory with the rings as well. Then just a few months later, in October of 2020, there was a Mars opposition coming up. So Mars comes close to the Earth once every 2 years. So taking advantage of this opportunity, I got this photo of the red planet. You can see the Martian North Pole as well with ice, as well as the red color and some clouds towards the bottom. So one by one, I started getting photos of every planet of the solar system. So here's my solar system portrait. From the top, you can see we have Mercury, Venus, Mars, Jupiter, Saturn, Uranus, and Neptune. And instead of the Earth's photo, I've kept an image of the ISS, which is the International Space Station. Here is a better photo that I captured as the ISS flew over India at an altitude of around 400 kilometers and at a speed of around 28,000 kilometers per hour. This ISS is a floating laboratory that orbits the Earth once every 90 minutes, and it has around 6 to 10 astronauts on board at most times. I've also captured the ISS as it transited over the Sun and the Moon, having calculated it in advance. These transits take less than a second on average. Then, with targets like planets and the Moon, I use a technique known as lucky imaging. It involves capturing hundreds of thousands of photos of the same target and then using software to determine the best frames. Then you stack those frames and you get the final result, which is much sharper than any single photo that you could take. So I've captured smaller features on the moon as well. This is the Clavius crater. It is near the south pole of the moon. It is around 230 kilometers in diameter. And some more features on the moon, like the Copernicus crater, the Tycho crater, and Montes Alpes, which is a mountain range. In 2021, I also captured a rare event, which is called the lunar occultation of Mars. This happens when our moon passes in front of the planet Mars as viewed from Earth. So I got this image just a few seconds after Mars emerged from behind the moon. So you can see the immense difference in scale, as you can see Mars and moon in the same picture. So in 2021, I started delving into the world of narrowband photography. Narrowband is a technique to image deep sky objects even from the center of light polluted cities. To do this, we use specialized filters. So these are narrowband filters which block out almost all the light except for a very small 7 nanometer slice of certain wavelengths which are associated with certain gases commonly found in nebulae, like hydrogen and oxygen. In conjunction with this, I use a deep sky camera, which is a monochrome camera. It is actually more sensitive than a color camera. And it also has a cooler built-in, which cools the sensor down to minus 30 degrees, which reduces imaging noise. So with this setup, I got images of the North America Nebula and the California Nebula. And here is the Andromeda Galaxy, which is the closest galaxy to our Milky Way. Some of these images have taken me weeks or months to complete from start to finish, and they have around 10 to 20 hours of exposure time. I think in today's world, we are all used to taking photos with our smartphones, which take less than a second. But I think there is something especially rewarding about working on an image for weeks or months, gathering data every night, and then getting the final result at the end. So it's a really unique way to do photography. Here are some more deep sky photographs I've taken. Now you might be wondering, since all these images have been taken at night, is astrophotography possible during the day? The answer is actually yes. Astrophotography is definitely possible during the day because many people forget that our sun is just a star as well, and it can also be photographed. Imaging the sun without the proper equipment or knowledge can be extremely dangerous because of the bright light. So I use either a white light filter or a narrowband filter to image the sun. The narrowband filter is tuned to the wavelength of the chromosphere of the sun. So it rejects all light except for a very tiny bit of sunlight. And using that tiny bit, I got images like these. So this is the full disk image of the sun, as well as the prominence that you can see. And this prominence is actually 5 times bigger than even our own Earth. Some more images of the solar surface. Now, I've also traveled to Spiti Valley in Himachal Pradesh, which has some of the darkest skies in India. The high altitude of 14,000 feet combined with the low light pollution enabled me to get images like these. So this is a deepscape image with a mountain in the foreground and the Milky Way in the background. Now, after imaging all types of astronomical objects, I found that one type of object intrigued me the more, which was an image of an eclipse. So there are a total of 6 types of eclipses, 3 lunar and 3 solar. Lunar eclipses are generally much easier to see because they are visible from the entire night side of the Earth, and they are usually lasting 1 or 2 hours. Comparatively, there are 3 types of solar eclipses which are rarer because since the moon is smaller than the Earth, the shadow is smaller, and it is only visible from a small part of the Earth's surface. And even in those, most eclipses are actually either partial or annular. So this is a partial eclipse where the moon doesn't align properly as it passes over the sun. And an annular eclipse is when the moon aligns, but it creates a ring of fire because it's not big enough to fully cover the sun. But the crown jewel of all eclipses is a total solar eclipse. This is the rarest type of eclipse. It is the only opportunity you have to see the sun's atmosphere with your naked eyes. This is called the sun's corona around the sun. And a total solar eclipse is only possible due to the cosmic coincidence, that even though the sun is 400 times larger than the moon, it is also 400 times farther away. So in our sky, they'll appear exactly the same size. When I started doing research on solar eclipses, I found that the last one in India happened in 2009, with the line of totality passing through states like Gujarat, Uttar Pradesh, Bihar. I didn't know about it at the time because I was just 9 years old, so I couldn't see that eclipse. But I started researching and I saw that there is one eclipse in 2023 which is about to pass through the Indian Ocean. So this is entirely over water, but it makes landfall in 2 or 3 very small pieces of land. A little bit of Australia, plus the island of East Timor and Indonesia. I chose the town of Exmouth in Australia as my observing location. This is a very remote place. It is around 1,200 kilometers away from the nearest major city, which was Perth. So I planned a trip out. I invited 2 of my friends from Astrophotography India, which is a community that I'm a member of. And together we rented a car. We spent 3 days driving up the Australian coast. And on the way, we got to spend nights in some of the darkest skies on Earth. Here you can see our car with the large Magellanic Cloud, which is a dwarf galaxy rising in the background, as well as stars visible at sunset. And you can see the 2 galaxies plus the Milky Way on the top. So after 3 days, we reached the town of Carnarvon, which is around 350 kilometers away from the eclipse line. So this was the closest hotel that we could find. So we had to travel 700 kilometers to and from the eclipse in one day. So we got extra fuel also because there were no gas stations in the area. Then we went to sleep very early. We woke up at 3:30 a.m. And at 4:30 a.m. we left, driving along absolute pitch black roads in the Australian desert. We had to slow down numerous times to allow kangaroos and porcupines to pass. And then after 5 hours of driving, we reached the eclipse site. So this eclipse site was a beach. It was already filling up with a few hundred daring Australians, as well as some eclipse chasers from around the world. We quickly set up our cameras right as the moon started entering the sun's disk. So this was one of the first shots that I took. You can see some sunspots also. And the day had started out very hot, but it started cooling down gradually as the day went on. And the moon continued to cover the sun. The light was also dimming. Now, one thing I'd like to mention is that I had gone with the idea in mind that my priority was to look at the eclipse and not to photograph it. Now, this might seem strange considering I'm an astrophotographer, but I've realized that in today's world, a lot of people watch the world through their smartphone cameras. Whenever they see something interesting, they have to photograph it. And sometimes while photographing it, they forget to look at it, or they forget to live in the moment. But the best memories are made when you keep the cameras away. So the duration of totality for this eclipse was just 63 seconds. So out of those 63 seconds, I'd allotted that half of the time, I'll step away from my camera, I'll just look. So that was what I had in mind. And just a few seconds before the eclipse started, the beautiful diamond ring appeared in the sky. This is actually a phenomenon that only lasts for 2 or 3 seconds. It is the last of the sunlight before the moon completely covers the sun. So after a few seconds, even that disappeared and totality started. This would just last for 63 seconds. The sight can't be explained in words. It can't be explained in a photograph. You have to be there to see it. And I definitely would have forgotten to take even a single photo if I had not rehearsed it many times over. The moon appeared like a sunflower in the sky. The whole sky was deep blue, and it was ringed by long coronal streamers of light. It appeared like a 3D object with a starry background. And I was really riveted by the sight. And I had an app on my phone which was telling me 30 seconds remaining till totality. So I quickly remembered to take a photo. So we had to set up a GoPro on the ground, and we turned and we took this photo. So that's me on the right, and you can see the eclipse sun above us. This was taken at around 31 seconds. And then we continued to take more photos. This was one of the most creative photos that I took of the eclipse. You can actually see the surface of the full moon also. This is possible because of a phenomenon known as earthshine. Earthshine is basically light from the sun, which leaves the sun, reflects off of the earth, then reaches the dark side of the moon, reflects back, and then reaches my camera sensor. So even though this is technically on a new moon day, you can still see the full moon. So the surface is always there, even though light is not shining on it on normal new moon days. And yeah, so we continue to take photos as the moon left, as the shadow left on its way to pass over Indonesia. To conclude, I'd like to say that you don't have to be an astronomy enthusiast to appreciate the eclipse. It is just a celebration of the dynamics of an ever-changing solar system. An opportunity for us to step away from the day-to-day life and just appreciate our place in the universe. because rocks are casting shadows on other rocks all over the galaxy. But it is only on this planet that we know of is someone actually there to notice them. I hope to travel to more eclipses in the future, including one in April of this year, which will pass over Mexico, USA, and Canada. And that's not all. 2026 in Spain, 2027 in Egypt. I want to try to go to all of them, leading up to the only Indian total solar eclipse that is left in this century. On the 20th of March 2034, an eclipse will pass over the state of Jammu and Kashmir, making totality over Srinagar. And I hope I've inspired at least a few of you who will be there with me that day, 10 years from now, as we chase the shadow of the moon together. Thank you.